Hello everyone, welcome to Unacademy. In this session, I will discuss another bitwise operator called as complementation. Operator. Bitwise complement. It is bitwise complement. How it is represented? By a tilde sign. This is called as a tilde sign. Okay. Sir, but before discussing this operator, let me discuss few points about binary numbers and how 2's complementation work and how signed magnitude work and what is the range of values we can store. So, just for discussion point of view, let us assume that we have only 4-bit number. We have only 4 bits to store number, to stored integer. We have only 4 bit to store integer. First, let me discuss signed magnitude representation. Sir, in signed magnitude, what we have? Sir, first bit is reserved for sign. So, first bit could be 0 or first bit could be 1. So, if it is 0, sir, the possible values in these places could be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. Sir, this means these are the positive values we can store. These are the positive values we can store, where first bit is for sign bit. That means what is the value? Sir, 0, 1, 2, 3, 4, 5, 6 and 7. That means for positive number we have values like this: plus 0, plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7. Sir, again, for the same 4 bit, sir, the signed bit could be negative also. Now, for these 3 places, again we have 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. That means we have minus 0, unfortunately. We have minus 1, minus 2, minus 3, minus 4, minus 5, minus 6 and minus 7. So if I ask you what are the possible values that we can store inside a 4-bit integer? So sir, values in negative, it is minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, minus 0. See, minus 0. Now we have plus 0, plus 1, plus 2, plus 3, plus 4, plus 5, plus 6 and plus 7. Sir, how many values are they? Try to understand. Sir, in 4 bits, how many possible values can be represented? 2 to the power 4, that means 16. 16 possible values can be stored. Let me count: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, sir, perfectly okay. But what is the problem? Sir, the problem here is 2 representations for 0. Sir, this is a complete waste. That means out of 16 values, out of 16 possible values that we can represent, that we can store inside a 4-bit number, 4-bit binary number, sir, we are wasting one value. First problem. And second problem is we have 2 representation for 0. That is plus 0 and negative 0. But there is nothing like minus of 0. First problem. Done. Sir, what we can do? Sir, can we save this value? Somehow can we save this value? Sir, we are wasting one value that we can store. Okay. Sir, can we save it? Yes, we can save it. How? Sir, instead of wasting it, instead of wasting it, sir, in 2's complement, this minus 0 becomes minus of 8. That's the beauty of 2's complementation. Sir, how it is possible? Let's see 2's complementation. Sir, what is the range in 2's complementation method? In 2's complementation representation, how we can save the value wasted by minus 0 in signed magnitude? Sir, we have 4 bits. Okay. For numbers which are positive, sir, 0. We have 0, 0, 0. 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. That means for positive numbers, see 0. By looking at this, we know in 2's, if I am following this, sir, positive numbers are stored as it is. How computer evaluate? By looking at MSB. If it is 0, that means these all are positive. That means, sir, we have numbers from 0, 1, 2, 3, 4, 5, 6, 7. Okay. Sir. What if I say, sir, we can have 1, 0, 0, 0. Okay, but what is this number? Let me calculate. Sir, if I show this number to a machine, computer or machine will look at this number and say, oh, this is a negative number. Okay. And negative numbers are stored in 2's complementation form. So what is this number? Sir, it will calculate the 2's complement. Sir, can we calculate the 2's complement of this? Yes, of course. How 2's complement can be computed? Sir, 2's complement can be computed in 2 ways. First way is, sir, from right to left, just copy all the bits until you get first one. Sir, 0, 0, 0. We get the first one, but unfortunately, this is the last one. That means, sir, the 2's complementation of this is this. That means, sir, we got the binary number like this. Sir, if I convert this into decimal, what is the answer? 8. That means, sir, see, this was the number which is minus 0 in signed magnitude. But here in 2's complementation form, this minus 0 is representing value minus of 8. That's the beauty of 2's complementation representation. Sir, okay, try to understand. Sir, what if I ask 1, 0, 0, 1? We could have 1, 0, 0 as well as 1, 0, 0, 1. Sir, see, now no need to compute 2's complementation. We have a direct method to calculate 2's complementation. Sir, how can we calculate the 2's complementation? By looking at only zeros. Sir, what is it? 2 to the power 0, 2 to the power 1, 2 to the power 2. Tell me what is the value? Sir, minus of 2 to the power 2 minus 2 to the power 1 minus extra 1. So what is it? Minus 4 minus 2 minus 1. Sir, this is minus 7. Okay. Sir. Please look at here. Sir, 1, 0, 0, 0 represent minus of 8. 1, 0, 0, 1 represent minus of 7. Sir, 1, 0, 1, 0. Let's see what is the value of 1, 0, 1, 0. Sir, let me directly calculate. I know this is a negative number. Let me calculate the value. Sir, it is in 2's complementation. So, sir, focus on zeros. So, what is the value? Minus of 2 to the power 2, minus of 2 to the power 0 and extra minus 1. So, minus 4, minus 1, minus 1. Sir, it is minus of 6. See, this is minus of 6. Sir, that means 1, 0, 1, 1. If you calculate, sir, is it in 2's complementation? Yes. Look at this one. Sir, can we calculate the value? Of course. Sir, 1, 0, 1, 1. Focus on 0. So 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Sir, minus of 2 to the power 2 and put a extra 1. So minus 4 minus 1. Sir, what is the value? Minus of 5. Sir, let us finish this. 1, 1, 0, 0. Sir. 1, 1, 0, 0. Sir, is it in 2's complementation? Yes. This first bit, MSB, will tell the computer that this is a negative number. Sir, can we directly compute? Yes, focus on zeros. Sir, it is 2 to the power 0, 2 to the power 1. So what is my answer? Minus of 2 to the power 1, minus of 2 to the power 0 and extra minus 1. So can I say minus of 2 to the power 1 plus 2 to the power 0 plus 1? Yes, sir. So minus of 2 plus 1 plus 1, that means minus of 4. That means what is the value? Sir, it is nothing but minus of 4. Similarly, if you ask me 1, 1, 0, 1, you can calculate. Sir, it will be minus 3. 1, 1, 1, 0. Sir, it will be minus of 2. Sir, 1, 1, 1, 1. Let me calculate this. 1, 1, 1, 1. 1, 1, 1, 1. Sir, is it in 2's complementation form? Yes, it is in 2's complementation form. How you know that? By looking at this one. Can we find out the value directly? Yes, just focus on zeros. Is there any zero? No, sir. Put a extra minus 1. So what is the value? Minus of 1. Minus of 1. Now, try to understand. We have all the values over here. Sir. For positive number, we have 4 bits. What is the range? Sir. What is the first value? 0. What is the first value? 0. Of course, we have already seen this. Sir, and the minimum value is when all the bits are 0. The minimum value is when all the bits are 0. Okay, sir. Sir, what is the maximum value in positive? See, the sign bit remains same, but we have all the bits as 1. When we have all the bits as 0, we get the minimum value in positive. Now, what is the answer? Sir, again there is a trick. If you want to compute, you can. Sir, what is it? Sir, this is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Can I compute? Yes, 0 into 2 to the power 3 plus 1 into 2 to the power 2 plus 1 into 2 to the power 1 plus 1 into 2 to the power 0. Can I say it is nothing but 2 to the power 2 plus 2 to the power 1 plus 2 to the power 0? Isn't it a GP, geometric progression of 3 terms with common difference as 2? If I write something like this, try to understand. 4 plus 2 plus 1. Can I write it as 1 plus 2 plus 4? Sir, it is a GP with 3 terms and the common ratio is 2. So what is the answer? Sir, 2 to the power number of terms minus 1 divided by common ratio minus 1. So what is the answer? 2 to the power 3 minus 1. Try to understand. Sir, if we need to find out the value of all ones, continuous one. For example, these are 5 1. What is the value? Sir, how many are they? 5. 2 to the power 5 minus 1 is the answer. No need to learn this formula. Sir, what is the answer? 2 to the power 5 minus 1. Let me calculate. What is the answer? 31. Sir, can we compute? Yes, of course you can compute. 1, 1, 1, 1, 1. So it is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. Sir, 1 into 2 to the power 4, 1 into 2 to the power 3, 1 into 2 to the power 2, 1 into 2 to the power 1, 1 into 2 to the power 0. What is it? 16 plus 8 plus 4 plus 2 plus 1. Sir, 24, 28, 30 and 31. Okay, we got the concept. Sir, we got the concept. That means if I ask you what is the maximum value, see, sir, 4 bits are there, one is reserved for sign bit. How many bits are left? 3. And what is the maximum value when all are 1? Just now we have computed when we have 3 ones, what is the value? 2 to the power 3 minus 1. So in positive, for a 4-bit integer, sir, in positive, we start from 0 and go till 2 to the power 4 minus 1, that is 3 bits are left for magnitude, minus 1. That means, sir, what are they? 0, 1, 2, 3, 4, 5, 6 and 7. Okay, sir. On the other hand, if I talk about negative, sir, these are the negative value. Try to understand, these are the negative value. Sir, in negative, what is the minimum value? The minimum value is again as same as positive. In the case of positive, first bit is for sign, so forget this. So what is the minimum value? When all the bits are 0, see, this is sign bit. When all the bits are 0, we get minimum value in negative. What is the value? You can easily compute. Sir, because it is 1, you know that it is represented in 2's complementation form. Sir, can we have a direct formula? Yes, you know. Sir, focus on 0. So again, 2 to the power 0, 2 to the power 1, 2 to the power 2. Sir, can I say minus of 2 to the power 2, minus of 2 to the power 1, minus of 2 to the power 0, minus 1. Okay, minus 2 to the power 2, 2 to the power 1, 2 to the power 0 plus 1. What is the answer? Minus 4 plus 2 plus 1 plus 1. So it is nothing but minus of 8. Can I say it is nothing but minus of 2 to the power 3? Can I say it is nothing but minus of 2 to the power 3? Yes, sir. Why? Think about it. Sir. While computing the direct value for a 2's complementation number, we are focusing on zeros. We are only focusing on zeros. So again, if I ask you, what is the value of 3 continuous 0? Sir, the same concept. If we are working on 5 1, what is the answer? 2 to the power 5 minus 1. Done, sir. That means if I ask you, what is the value if I focus on continuous zeros? Sir, these are 3 zeros. That means the value will be 2 to the power 3 minus 1. Done. What is it? That means this is minus of 7. Or let me put it the same way, 2 to the power 3 minus 1, but they are of negative because we are working on negative number, and we put always we put an extra 1. So let me calculate minus of 2 to the power 3 plus 1 minus 1. So what is the answer? Minus of 2 to the power 3. That is, see, 1 bit is for sign, 3 bits are remaining. In negative, we have minus of 2 to the power 3 as the minimum number, because we are working in 2's complementation. So the smallest value over here is minus of 2 to the power 3. Sir, what is the largest value? Again, the largest value will be when the sign bit is 1 and all remaining bits are also 1. Sir, when all bits are 1, what is the value? See, is it in 2's complementation? Yes, sir, it is in 2's complementation. How to find the value? Sir, focus on 0. Is there any 0? No, sir. That means put a extra minus 1. So what is the value? Minus 1. That means what is the largest value in negative? Minus 1. Try to understand. Sir, what are the values? Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8. And what about positive? 0, 1, 2, up to 7. So, sir, for 4-bit integer, we get to know that the positive values are nothing but from 0 till, see, 1 bit is reserved for sign. Remaining 3 bits, within remaining 3 bits, how many numbers can be represented? Sir, 0 till 2 to the power 3 minus 1. We have already covered this topic in data types. I hope you must remember this concept. Sir, for negative number, the largest value is minus 1 and it goes till minus of 2 to the power 3. Sir, if I ask you, what about 8 bits? Sir, in 8 bits again, inside positive, 1 bit is reserved for sign bit. Remaining 7 bit. Sir, out of remaining 7 bit, total values that can be computed is 2 to the power 7. Okay, sir. Okay, let me again compute it. Don't worry, everything is okay, sir. If we have 8 bit, 1 bit is reserved for sign, sir, 3, 4, 5, 6, 7. Sir, what is the minimum value? When all of them are 0. That means the minimum value is 0. What is the maximum value? Sir, first bit is again reserved for sign. Sir, that means out of these 7 bit, sir, what is the value? The maximum value is when all the bits are 1. What is the value? Sir, 7, 1. Contiguous 7, 1. What is the value? We have already computed it. 2 to the power 7 minus 1. So for 8 bits, sir, positive values start from 0 and goes till 2 to the power 7 minus 1. Why? Because the maximum value occur only when all the bits except the sign bit are 1. That means n minus 1 bit. Okay, sir. Sir, for positive, it is completely okay. Coming to negative, sir, please try to understand this. This is very important topic. Sir, what is the minimum value when first bit is 1, because we are working on negative numbers, and all the remaining bits are 0. Sir, how many are they? They are 7, 0. Do you want to compute in 1's complement, then find 2's complement and all that? No, sir. We don't want to compute that. Then, sir, how we can compute? Sir, in direct method, we focus on zeros. So they are 7 zeros. So what is the value? Sir, how we compute? Let me explain. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 5, 6. One way is focus on zeros and put a extra 1. So if you try to compute, it is nothing but minus of 2 to the power 6, 5, 4, 3, 2, 1, 0 and extra 1. You can calculate it easily. Minus of 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 plus 1. Sir, what is the value? If you want to compute, I can. 2 plus 2 is 4, 4 plus 4 is 8, 8 plus 8 is 16, 16 plus 16 is 32, 32 and 32 is 64, 64 and 64 is minus 128. This is the first method you can compute. But here, sir, can we compute it directly? Yes, of course you can compute it directly. Sir, we are working on 2's complementation form, and to compute a direct value, we need to focus on zeros. Sir, we have 7 contiguous 0. Sir, what is the value if I ask you? We have contiguous 7, 1. Sir, the answer is 2 to the power 7 minus 1. 2 to the power 7 minus 1. Okay. But here, what we have? Contiguous 0. Sir, here we will focus on 0. So, what is the value? 2 to the power 7 minus 1. But since we are working in negative number, the value is this. Sir, and always we put an extra minus 1 in direct method. So what is the answer? Minus of 2 to the power 7 plus 1 minus 1. That means minus of 2 to the power 7. Or can I say minus of 2 to the power the number of bits? Sir, how many are they? They are 7 bits. So the minimum value is nothing but minus of 2 to the power number of bits. And what could be the maximum value? Sir, for negative, what could be the maximum value? Sir, the maximum value always occurs when we have all 1. So this is the sign bit. We have 1, 2, 3, 4, 5, 6 and 7. Sir, we have all 7 bits. Okay. Sir, can we compute the value? Easily. Yes, of course. Sir, because of this one, computer understand that this number is in negative form or in 2's complementation. In 2's complementation direct method, what is the answer? Sir, we focus on 0. Is there any 0? No. Is there any 0? No. That means, sir. But we put a extra minus 1. So what is the value of this number? Minus 1. So the maximum value in negative is minus 1. The minimum value is minus 2 to the power number of bits used to represent the magnitude, basically except the sign bit. So for the same concept, sir, if we have n bit, if we have a n bit number, if we have n bits to represent an integer, to store an integer, sir, in positive, one bit is reserved for, one bit is reserved for sign. Sir, out of n minus 1 bits, we have n minus 1 bit. The minimum value will be, sir, all are 0. That means the minimum value is 0. And what could be the maximum value? Sir, 1 bit is reserved for sign. Maximum value occur when all the bits are 1. Sir, do we know? If we have 5 contiguous 1, the value will be 2 to the power 5 minus 1. If we have 7 contiguous 1, the value will be 2 to the power 7 minus 1. Now we have n minus 1 contiguous 1. So what is the value? Sir, the value will be 2 to the power n minus 1 minus 1. So what is the range of positive number? Sir, it is nothing but 0 to 2 to the power n minus 1 and minus 1. Done. Okay. Sir, for negative, what could be the smallest value? Sir, the smallest value is sign bit and remaining n bits are 0. Sir, can we compute the value directly? Yes, of course you can compute the value directly. Or you can take 2's complement. Sir, if I wanted to compute the direct value, we will focus on zeros. How many zeros are there? N minus 0. Just like ones. Sir, what is the value of n minus 1 contiguous zeros? Sir, it is nothing but 2 to the power n minus 1 minus 1. But, sir, these are of negative. And we always put a extra minus 1. So, what is the value? What is the minimum value? Minus of 2 to the power n minus 1 plus 1 minus 1. That means the minimum value in negative is nothing but minus of 2 to the power n minus 1. And what could be the maximum value? Sir, the maximum value occur. See, this is very important topic. The maximum value occur when all are 1. How many are they? N minus 1. Sir, how can we compute the direct value? Focus on 0. Is there any 0? No. That means the value is 0. But we always put a extra minus 1. So what is the value? Minus 1. So in negative, what is the range? Sir, it is nothing but minus 2 to the power n and it goes till minus 1. So what is the final range? Sir, this is the smallest value in negative and what is the largest value in positive? 2 to the power n minus 1 minus 1. Or you can understand it like this way. We have minus 1. Sir, please calculate it for 16 bits. If you have 16 bits, then in positive you have 0 to 2 to the power 16 minus 1 is 15 minus 1. That means 0 to, what is 2 to the power 15? It is nothing but 32768 minus 1. That means what is the range? 0 to 32767. Sir, in negative, what is the range? Sir, the largest is minus 1 and the smallest is minus of 2 to the power 15. That means minus 32768 minus 1 and in positive 0, 1 till 32767. So that's how we can compute the range. I hope you must get the clarity how numbers are stored, how numbers are fetched, how we can compute the range of any number in n bits. So that was about number representation in 2's complementation form as well as in signed representation form. That's all for this session. I know something is missing. What? Complementation. So in next lecture we will discuss complementation. basically bitwise complement. So bye bye, take care.